Hello, in this video I'm going to show you how to create a target wavefront directly in the PlanOpSim software. To do that, as an example, we will make an aspheric lens, a small meta lens, created directly in the user interface. So we will start by making a meta component here in the meta component module with dimensions of 100 by 100 microns. And as meta atoms, I've selected a group of circular pillars. Now, the next step is to define what the target wavefront should look like. So we can go into the target tab here and add a design target, for example, this one here. We modify it to the settings of our liking. So we will call this a script target. And we are interested in getting the complex wavefront reproduced for TE polarization. We can save this. And now go to defining our near field wavefront. There are two ways to generate the target wavefront. So one is by uploading it externally. The other one is by going here and clicking the pencil icon, which will open up a pop-up containing a little script console where we can generate our own wavefronts from a Python script. We can select we can build a script either from scratch or select one of the examples here. In this case, I will take the aspheric lens, which will then need to have two things set. One is the amplitude of the wavefront, of the complex wavefront that we're making. The other one is the phase. And on top of that, there are some parameters to set in this case, but this is completely free, of course, in what you choose to define. So let's make a lens with a focal distance of 100 micron and give it a circular shape also. So I will make a mask here, a circular shape. Inside the script, there are some preloaded variables. Most importantly, the dimensions of the meta component and the size of the unit cells is already known in the shape of the X and Y variables. So there is no need to define that separately. All we have to do is translate the amplitude, create the amplitude and phase of our cells. So we have the amplitude and phase defined. I can then click generate. This will bring up a preview of the wavefront I made. So in this case, I'm having a 100 by 100 grid for the amplitude, which is which has a circular mask. And if I look at the phase, I see the concentric rings that I expect for a focusing lens. So when I'm done with that, I can confirm. And then we should see that also our wavefront is updated here. This can take a moment because it needs to upload. And here we have the wavefront that we generated from script ready to use in a meta lens. If we now want to generate that meta lens, we can simply go to the design tab and click start design. This will start a new design and we need to give it some time to run and complete the design. So this is done now. We can inspect our design through the GDS mask here. We can click mask to download the mask. And here we have it. Our series of concentric rings are also coming back in the GDS mask design. We can zoom in, have our series of pillars defined here. If we look inside the layer, we also see all 8 of our structures are being used inside the design. So like this, we can directly define the wavefront target in the PlanOpSim software and send that to the design in order to generate the GDS mask and further analyze it later on.